Hello students, how are you? I hope you are doing well. I hope you are doing fine. You are happy, you are healthy, you are, perfect, right? So I want you this way always, right? I don't want you to be depressed, as I feel like mostly nowadays I'm off my mood. My mood is not that good. But yes, I'm trying to focus on other things. And I want to spend the rest of my time with the people who are waiting for me, right? For the people who are waiting for my lectures, who are waiting and who are checking on my next videos, right? Those who are not, fed up from me or my talks, right? Though I am a very talkative person, I am very entertaining, I am full of life, and I believe in live and let others live, right? Live your life and let others live also. So that's what I believe in. Well, anyway, so I'm here again. So this is your Professor Dr. Moina Akhtar from Dr. M. Kazi, Institute of Chemistry, University of Zin, Jamshoro. I think this you have been listening since months and months and months. So I just need to know now at this stage that after, the passage of so many months, how did you find me? What faults you feel like that I am having, you should tell me, and so that I can remove them, right? Because teacher is not, an angel or somebody, an extraterrestrial or something, or a computer. No, a teacher is also a human, right? So a teacher can do mistakes, and I do a lot of mistakes, and my videos and lectures are all without editing up till now. So from now on, I will try to, I will try to focus more on my mistakes. And most probably these are not mistakes. Actually, sometimes I don't remember what I read, and I read many books, and then I put together all the things on some paper, and then I try to present it to you so that it will become easier for you people, right, to follow. So I hope you are now, as you are improving your papers, you are doing well. It is for those who are improving their papers, I wish you all the good luck, and I hope you are doing all well, and this time you are doing your best. As I told you, you must read all those guidelines which are provided to you for all those who are improving their papers, for all those who were trying to strive for the better results. So I was trying to, I gave them a lot of hints, right, in my last guidelines regarding improver and failure. So please go through them, and it's not only for improver and failures, it's all for all the students who are regular. Even you should try to follow the steps, and even in my next few videos I'm going to explain it to you, other things that will help you out in attaining better marks, in getting good marks, and the way how you are supposed to follow, your timetable of your study timetable especially, and how you are going to monitor your this timetable, that whether you are on your timetable or you are off from your timetable, because sometimes we plan it on the paper but we are not following it. This is sometimes we do it. So last time I was discussing with you something about glass, right? We were talking about glass is everywhere. So I want you to see few of my glass collection which I have, and I want you to see it from your own eyes. I hope you will like it. So this is, my dear student, these are the beautiful vases. I've told you I have a little bit collection of vases. So these are my vases that are lying in my own home, right? These are all so beautiful, and they have such beautiful, lovely colors. You can see them easily, the colors they hold. This is all glass, right? All glass, and this is a glass, of course, to drink some water. And these are special pens. I want to show you these special pens. These are from Milano, right, Italy, where this glass work is being done, right? The glass work is being done, right? And this is, the top is made up of the crystal. These are actually the pens, right? These are glass pens. These are, you can hear the voice of the glass. So these are beautiful. They have beautiful colors. I had 4 of them, and now I think one is broken. So I'm left with these 4 colors, and these are, the most beautiful thing that can happen to anyone. These are the glasses, old time glasses that were dipped into the pen, into the ink, and then they were used to write. So these, you can hear the voice of the glass. It's beautiful. So I was telling you about these beautiful pens that they are made up of this glass, right? Just look at them. Just look at the colors, and just look that from the top to the bottom they are made up of glass, and these are from Italy, Milano, right? It's a beautiful city over there where all this glass blowing and everything regarding glass is done. Okay, so these are some beautiful vases that I have at my home, right? And I wanted to show the blue one also. This is also very pretty. I'll just love this blue color very much, so I picked it up from my haul and I brought it here for you people to see. That just look at them, how beautiful and how shiny these vases are. This is something new in these shops, and just listen to the voice of the they are giving us, right? Such beautiful colors they have. This is all glass. And now the next collection, this is something, a decorative piece you can call it, right? It's a small ashtray or some sort of a glass tray, right? It's also for decorative purpose. This is my flower vase, and which I always love to pick and see and show it to you people. This is beautiful. I just love this flower vase very much. And I have beautiful flowers lying in them. I just took them out for you people, and this is something lovely which I wanted to show you, huh? Such small, it's sort of a bucket or what you can call it, I don't know. Just look at the color of this glass. It's beautiful, right? When you do this, you can hear, yes, it is glass. So these are all the things that are made up of glass, as we are talking about glass. So I thought that I must share some beautiful items that I have with myself and that will add up to my video, and you will like it. That yes, our teacher, she showed us beautiful glass, and there are many other glass items also lying in my place, but I thought I should show some of them, and I brought them with real care upstairs, and I thought that I must show it to you people. And you must have a beautiful look on these glasses, right? So this is the glass we are talking about, how it is made in the industry, right? How it goes on in the industry, how many workers are working on them day and night to get you this form of beautiful form of glass, how they shine. They are all polished, right? And they are brittle, they are breakable, and they are not that much, they don't hold that much stability. Maybe it's because that they do not have that much stabilizers in them. Those that are breakable, they don't hold that much stability, whereas those who are not that they are hard ones, they hold the stability. As this was, it dropped once on the floor and then it was not broken, and I was amazed. Oh my god, it was saved. But these ones, I'm sure, God forbidden, if they fell down, they will never, they will definitely break. So maybe the stabilizers. Now what are stabilizers, what are fluxes, what are there are a few terms which you don't know. I'm going to teach you today what are these things, and what is the role of stabilizers in the glass industry, what is the role of fluxes, right? And what are all these things, and how the glass is manufactured, what is the process of manufacturing the glass. So I will explain you each and everything in a nice way today. So let's get back to our topic, okay? And let's get back to the beautiful world of glass industry. Hello students. So I'm back again. I just showed you a lot of things regarding glass, and I showed you the glasses, the type of glasses I have with me, and I thought that you like all these things very much, because these things add color to our life. The colored glasses, I just love colored glasses. I think you must also be loving the colored glasses, right? So I love it. So I hope you're all good now. And how's your health? I hope everybody's doing fine. Nowadays you are going through your examination process, so that is also something very tough and something, I mean, very challenging for everyone who is striving to get the best results, right? So last time I shared a few lines regarding, I mean, what is glass, and is it crystalline, is it amorphous, why it is called cool, or you can say super cooled solutions, or why silicon is the most you can say commonest cation that forms this glass. So dear students, 4,000 years ago glass was discovered. It's, I mean, years, 4,000, not 2-3 years, it's not a matter of few years, it's a matter of 4,000 years ago glass was discovered, and it is the most widely or commonly material that has been used since, I mean, centuries, right? So glass was responsible for managing light, where of course light or heat in indoors and outdoors, right? That is for the indoors also and for the outdoors. Now silicon dioxide, that is silica, that has the percentage of 72, 75 or 74% is the major compound in the composition of the glass, right? When you talk about the glass composition. So the rest are CaO, this calcium oxide, it's 11%, and then magnesium oxide, then Na2O, it is 16%, whereas magnesium oxide is less, it is only 3%, right? So major ingredients are required for synthesizing glass are 3 in numbers, that is number 1, formers, fluxes, and stabilizers. These are the 3 things which you are supposed to focus on when you are going to study, I mean, the composition of glass, right? What are those? Formers, fluxes, and stabilizers. All have different different functions, and all hold different responsibilities in the glass industry, and all will play their role. And what is that role? I'm going to explain it to you now. Any glassy material holds a key component, that is glass former, right? Commonest formers is silicon dioxide, SiO2. As I mentioned earlier, that pure silica has a high melting point, that is around 1723 degrees centigrade or 3.133 degrees Fahrenheit, right? So here comes the role of fluxes. Now fluxes come into action. What are fluxes? F-L-U-X-E-S, fluxes. Now these are, of course, they might be holding some function. What is their function? Their function is to lower down the melting point, right? Or melting temperature, right? So what are the 3 basic forms of fluxes? These are boric acid, that is B2O3, phosphoric pentoxide, phosphorus pentoxide, that is P2O5, and they have low melting points. They hold very low melting points. That is the reason that they have been chosen as the best fluxes for the glass industry, and they hold the temperature between 400 to 600 degrees, right? And it ranges between degrees centigrade, and that is 752, you can say 1.112 degrees Fahrenheit. So these can be used but avoided due to their low melting properties, right? And as they are diluted easily in water, they have a dissolution in water, and that makes them, I mean, that prohibits their, I mean, further progressing, further their usage, and that that is the major limitations, right? So this is one of the reasons that why, I mean, you can say why this is all being avoided due to why. It's because of its low melting property, that it is simply dissolving in water. So anything that is dissolving in water is not stable, right? It's not that stable. Dear students, let's get back to our the topic where it was discontinued because the shortage of time. So I was talking about the fluxes. So the standard fluxes are soda, that is Na2O, potash, K2O, lithia, Li2O, NaNO3, Sb2O3, CaF2 etc. So these are all the common fluxes that are used in the glass industry. Anyone can ask you the name, so I'm just mentioning it again and again so that you can memorize them and you can put them in your memory and just read them, go through them again and again. As I'm telling you, the teacher is the teacher. He cannot feed anything and he cannot make you put forcibly anything in your mind, but I will try my level best to get all these things absorbed by your brainy, right? So silica glass holds added flux. We are talking about flux. So silica glasses, they hold added flux, right? They have some additional fluxes as they are used to lower down the temperature, which I just told you. It helps silica to melt at lower temperatures, that is between 800 to 900 degrees Celsius. Now mostly fluxes is added as a carbonate, right? Now there is a form that is carbonate, that is like sodium carbonate and H2CO3 carbon, and during that process carbon dioxide is evolved during the heating, as high heating temperature has been given, so carbon dioxide is evolved during the heating process of the glass. And if a glass has only silica and flux, they are no more durable as they are water soluble, which I just mentioned before, right? So this is one of the property, that if they have as only silica in them, if they have only flux in them, they are not that much durable, they are no more stable, their stability loses, right? They are, if something is water soluble, that means it doesn't hold that much stability, it's not that much stable, right? So what is stability? If you are a chemist, you should know what is stability, and if you don't know, just put them in the comment section and I'm going to explain it to you what is stability, right? I will let you know. So now let's talk about stabilizers. What are stabilizers? As I was just telling you, stabilizers. Stabilizers. So stabilizers make glass more durable, as I just mentioned, right? More stronger. For example, what is the example? Lime, right? CaO, lime. MgO, magnesium oxide. Baria, BaO, right? These are the examples of the basic stabilizers that are used, right? So the glass used to make windows, bottles, jars, light bulbs is the most commonly used by ancient and the modern glass makers, based on what? Three things: silica as glass former, number two, soda as a flux, and lime as stabilizer. What are those three basic things? Silica as a glass former, soda as a flux, and lime as a stabilizer. So you must you must go through these things, and you must remember that these are all the forms of the stabilizers that make glass more stable and easily usable for our daily purposes, because if they are brittle, if they are breakable, then we will not be able to handle them. Their handling is difficult. Even in the manufacturing process, the stabilizers are added to make them more easy to handle, right? So because nowadays all the robots are doing this machining, right? The machine, it's not manual anymore, it's all robots that are they are functioned, they are programmed in a way that they are handling the glass, right? But it's a beautiful process, and in one of my videos I'm going to show you how the float process it goes. It's a beautiful thing, the float board or the float process. It's beautiful, and I've seen many times, and it's just amazing to see the glass industry, right? And how the colored glass, and there are so many types of glasses which I'm going to explain it to you in my further lectures. And the glasses have different colors, and what colors make them what is the role of colors in their synthesis. It's also beautiful because colors makes your life beautiful in every way. Color is everything, I hope. So without colors, our life is color, it's nothing. So hello students, now I'm back. So let's discuss now the manufacturing of glass, right? How the glass is manufactured. So Sir Alister discovered in 1952 that one could manufacture glass in 6 stages, right? There are 6 stages in which one can synthesize the glass, right? So and these 6 stages, they play a very important role in the manufacturing of glass. Now what are those 6 stages? That is, number 1 is melting and refining. Now batch, you can say raw materials are. A batch is formed. What is batch? It is a mixture, or you can say a mixture of something composed of raw materials like Na2O, feldspar, dolomite, silica sand, and calcium oxide. These are all mixed up, right? They are mixed up and then they are heated above or around 1500 degrees Celsius, right? In a furnace, as I just mentioned in my previous lectures also, that a furnace is used to heat to that level, I mean to that extreme level of heat is applied, and metal oxides, now they come into the ground. Now they are there for some reason. They are there to provide the beautiful colors to the glasses, right? We love the glasses that are colored, right? So iron is there to get the green color, sulfur is there to get the blue color, manganese is there to get the black color, and cobalt is there to get the blue color, right? And nickel is there to get the gray color, selenium, bronze. So there's a huge list of metal oxides that are there, and they will be added to the glass, and they will give us the beautiful colors that are desired, right? That are desired. So I hope you like this first stage, that is called the melting and refining, and adding of different metal oxides to them. And I just told you the key points of this metal and refining. Please go through in detail about this topic, right? It's not end up here. You have to add up many other details into it, right? Go through them. So my dear viewers, hope you are enjoying the glass story, right? It's a glass story told by Dr. Moina, right? So I was telling you about the metal oxides that will be added, and you are going to get the beautiful colors of these different glasses. I just showed you also in my first video, right? In the beginning of the video. Now we'll discuss the second stage, that is very important, and it is called float path. I will hopefully in some presentations I will show you how the float path works, right? So what is the float path? Well, it's some sort of a machinery, right? It's a machine, a long, very long machinery in which some sort of raw materials are added first, and then they are mixed together and they are added, and then they start flowing over the sheets and into the ribbons, and then they are very super hot like lava, and then they start cooling, and then they are attaining the shape of some sheets, glass sheets. Then they are this is a whole process of float path. I just told you in few words, right? So now what is happening here? Silica sand, that is limestone, etc., are added into the furnace around a very high temperature, that is 2900 Fahrenheit, and it looks, at that stage it just looks like lava, right? And it is allowed to run on a tin bath. Then after that, after they're running on the tin bath, then around the temperature lowers down a bit, around 2000 degrees Fahrenheit, turning into sheets of red hot glasses, and then it flows over the refiner, that is other part of you can say a furnace, right? Then again it starts flowing through a tapered or you can say tapered canal. It is a tapered canal like thing where it is monitored. Then it flows the molten tin area. So this glass is called ribbon that floats on the surface of the tin, right? It floats on the surface of the tin. So the thickness of the molten glass is 6.9 mm, right? It is measured, and it's not fixed, but it is measured by the workers that are, the scientists that have the brains that are working behind all those machinery that is making all these, that is going on with this float bath process. So the thickness of that they mentioned that the thickness of the molten glass is around 6.9 mm and is uniformly flat, right? It is totally flat on top and bottom, as it is still So it's still, you can say the thickness of, as I told you, it's about 6.9 mm and uniformly flat, right, on both the top and the bottom, as it is still floating on the tin bath, right? It is still floating on the tin bath, and is still, it is in the liquid state, right? It's not, I mean, they didn't solidify yet. It's in the liquid state yet. So the machines on either side of the bath, there are, you know, it's a machine, it's a full, I told you, it's a full machine, and it looks so beautiful when you see a float bath. Well, let's continue with where I've left. So the machines on either sides of the bath, attaining a pipe shaped, having a wheel at the end, it has got a wheel at the end, are for pulling the glass down the bath, right? They are just for pulling down the glass down the bath at about 90 degrees angle. The angle is there at about 90 degrees angle with respect to the glass. It is like that with respect to the glass, right? So it is programmed. It is programmed to attain width and thickness of glass by pushing and pulling in this way that angle is added or subtracted, right? So the glass is allowed to progress further down the bath, and it hits the temperature where it gets hard to hold its shape. I mean, it gets to that level where it can easily, attain the shape, right? The ribbon is then removed from the tin bath and allows to move forward, right? It moves then further forward to a leher. It's called leher, L-E-H-R, leher, that monitors, regulates the cooling to make sure that glass will, you can say, will be of the quality they are looking for, right? So you can say a speedy cooling to make sure that glass will be of that super quality they are looking for. So this was something about the float bath. It looks so beautiful. It has different temperature. In the beginning it is, very hot, but when it goes a little bit further, it starts cooling down, and then in the end, I will further tell you in detail. Right now I'm getting tired. So the cutting process is also there, and it's beautiful when the glass has been cut by the robots. Robots are cutting them into squares or into the desirable shapes they need, right? It just depends that what type of what they are looking for, right? What desired products they are going to make from that glass particularly, so they will shape it accordingly. So it's a beautiful process. The glass industry is beautiful to look at. I hope and I will pray that I will take you to some glass industry in the site areas, and I will look for I will ask my seniors, though there are few seniors left whom I don't want to ask, but I will try to ask the seniors whom they are being monitored, so that you will be able to see the beautiful things that are not being provided to you people as a students, because you deserve much more than this. You are all very lovely students, and you are getting the response I'm getting you from you people as my students is just amazing, and I'm very happy that I've started teaching online in this way. You know me now as Dr. Moina, because you were never familiar with my teaching skills. You never knew me. You knew only few teachers of Dr. M. Kazi who are teaching you. I don't know what they are teaching, but what they are teaching you in the closed doors. So behind the closed doors, I don't know. So one should come up and they should face the camera, and they should speak for itself, right? And the teachers, there are many teachers who are teaching now who have took this initiative, and I appreciate their efforts. I appreciate all the efforts of my staff that is working along with me, and I'm grateful to everyone. I'm extremely helpful, and I'm extremely happy with everyone. Whoever played the part, I'm happy with everyone, because I love teaching. I love being a teacher, and I dedicated my whole life as a teacher, only as a teacher, and now as a researcher. I have been now in the research mode. I am supervising so many MPhils and PhDs, and I don't have enough time to record these lectures. If I'll tell you the time, at what is the time I'm recording, you will not believe it that at what time I am recording this lecture. Well, anyway, I hope you like this, and I'm very thankful the comments you are giving me, and please put all your comments and your questions in the comment section so that I can I can answer all your questions there. And I hope to see you again in the next stage, because there are 6 stages we are going to cover, so I'll inshallah continue it. Hello students. So I was telling you about the different stages of the manufacturing of glass. So let's discuss stage 3, that is coating. So as the glass flows down the floater, number of coatings are deposited over, right? So what are those coatings? You just go into the detail and you will come to know what type of coatings are being deposited over them when they start flowing down over the floater, right? So now we'll discuss the stage 4. This is annealing, A-N-N-E-A-L-I-N-G, annealing, right? So this is the process. Now what is this process? This is a process where glass is allowed to slowly lower down its temperature by cooling, and and internal strains are abolished to enable its possibilities for cutting and for making into the shapes we are desired or we are looking for. And the quality and strength of the glass can easily be calculated by by monitoring the way it is being cooled, right? It is being cooled, and if it is cooled in a short time, or it can be breakable then, right? So it is the stability is lies on the fact that if it is cooled in a very short period of time, it can be brittle and it can be easily breakable, right? So now we'll come discuss the stage 5, that is inspection, right? As the term tells us, to inspect something, right? You are now going for the inspection section. So this process presents 100 million inspections per second, right, on that ribbon on which the glass is moving on, right? And this is so beautiful to know that as I told you, the robots, it is all programmed, it's all computerized. So how many 100 million inspections are done on every second, right? This is called the inspection part of that flowed path, right? So stage 6 is cutting, right? The cutting of the glass. Now here the computer is fed, right? As it is all programmed, it is fed, and the required measurements to cut the glass. Measurements are recorded or provided to the computer, are fed down to the computer, and the cutting is done accordingly, right? So now students, this was all about the manufacturing of the 6 stages of the manufacturing of the glass, right? So now in the next video we'll be discussing about some interesting properties of glass and types of the glasses, and what is the role of different chemicals in them, right? The other aspects that are related to the glass industry, I will be happy to share with you people, because the glass industrial is a very industry is very interesting to see, to watch. And if I will get the I will have the opportunity, I will take you to some glass industry to see from your own eyes that how did I explain, and did it match with what I taught you. Whatever you will see, is it comparable to what I taught you? Because I teach you from 5-6 books, and then I look for all those information in the internet for the latest things that are there, and then I reproduce them, and I give put them in front of you, right, as a teacher. So I do a lot of hard work for you people to make you understand what I'm teaching it to you. So I hope you are following this glass the world of glass nicely. Now the chapter is not finished, it is just the half of it. The next inshallah hopefully I will be explaining the other things also. I will see what's next and I will explain it to you. And if you have any questions, I am again saying put them in the comment sections. And if you are happy, fine, no problem. You just go and share among your friends, and you can share with the people you like, people you love, right? And you are most welcome to come and ask me if you are not following my lectures from anywhere. I hope you are getting me now as a teacher. You know me very well, and you know everything. And in this way your English will also get better. That is the main thing. So see you soon. Bye bye.